T-score. So
Sweet.
I think I just got to write up the paragraphs now if I'm correct.
Okay. Let us know if you want us to do any of that too, or help with it.
Okay, will
Whatever.
do.
Yeah, for sure.
Um, for the homework quiz for lesson 23,
Yeah.
I ran into my first little problem. I I had downloaded the zip file with all these Excel sheets in it, so I opened that one. I did it and I got a 50% on the quiz. I was like, what in the world? So I was emailing the TA and stuff. The link on the quiz for that data has everything to like three decimals, whereas the first thing in that zip file had the same file but only one decimal. Anyway, it was
Oh,
crazy.
gotcha. Okay.
So make sure you use the links that are in the quiz from now on, now that we're done.
Oh,
Okay,
okay. Wow.
very sneaky.
Yeah.
Did
Anyway,
did she let you redo it or?
I had only taken it once, so it worked
Oh,
fine.
okay. Good.
Sweet.
All right. Should we
It
start
was
with the
kind of
prayer?
crazy. Yes, and we are live. Cool. I'll sit.
Okay.
Our Father in heaven, we thank thee for the blessings thou givest to us. We are grateful for thy Son and all that he does to help us learn and grow and prepare ourselves to return to live with thee. We pray that thou will guide us as we go through the study guide, that we'll understand the things that we've learned this semester, we'll be able to remember it all, and that we'll be prepared to take the exam and do well. We ask thou bless us as we continue on the project, that things will flow together well and we'll know how to word things right and do our very best. We pray for our families and we ask thou bless us to do well and to in sharing the light of Christ this Christmas season. And these things we pray for in the name of Jesus Christ. Amen.
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 Okay. Or get to open it up.
I've got the quiz open.
Yep.
Perfect.
Same here.
Okay.
Number one is true, just so you know.
Okay.
I
That was
got
the one.
that one right.
Yeah, that was the one I was hung up on. Okay. Perfect.
Thanks.
All right. Question 2. Which of the following is or are quantitative? Telephone number, brands of a car, number of people in a randomly selected classroom.
Be
Number
the
of people.
Yeah.
first and the third one, right?
So I went back and I looked it up, and for a telephone, it says like when you
Even
have a
though it's
list of
digit,
numbers, right? Like, can you add one or can you like, subtract by two and still like that number is still relevant or like the division or something? So since it is numbers, it gave the example like telephone numbers are categorical.
Okay.
So
yep.
that one, it's a trick one.
Okay, so it's just the third one then.
Yeah.
Interesting.
Okay. Who wants to go next?
I will. 3. Students in an introductory statistics class at BYU, Idaho were studying prices of cold cereals at a grocery store in Rexburg. To get a sample of cold cereal prices, they went to Albertsons and rolled a die to decide which box from the left to stop of the top shelf they would start on. They then would recorded every sixth cereal after the first, moving from left to right down the shelves, recording the name, size, and price of each cereal in their sample. Is this study an experiment or an observation, and why? It's an experiment um, because they're selecting specific ones out of it to do their study on, not just watching and seeing.
So the
And I
fourth.
think it's the third, that an experiment because the students had control over which sampling method they used.
Sampling. Okay.
What do you? I don't know. It's
I
one.
don't really know the difference between the third and the fourth.
Third's just talking about the method in general of which they pick the cereals, and then the fourth one, I guess, is just more broad, saying that they were able to pick which cereals in general.
I think the only thing that makes me say the fourth one isn't right is they didn't have the control to just say, I want to pick all the Kellogg's brand cereals kind of thing. They had to use a
Oh,
systematic way.
that's
That's
true. It's not. That's true because the fourth one almost makes it sound like it would be a little biased. Correct?
I think. This is my guess.
Okay, I think I see what
And
you're
I think
saying.
this
So yeah.
one's there's only one right answer, so that's my guess.
Okay. Cool.
Okay.
All right. And the next one, question four, is for a Math 221 project. One group of students studied the ages of students on the BYU Idaho campus. They collected data from from a random sample of n equals 100 students. The sample mean was 21.2, and the sample standard deviation was 2.61. An excerpt of their data is given below, and the group notices an error in their data. The age of one of the males, ID equals 3, was entered incorrectly. He is actually 21 years old. When the error is corrected, what will happen to the sample median? Okay.
Um. Hmm. Well, I don't know.
So say we had just the if
Wouldn't
we
it
just do the
increase?
numbers there,
Right.
say the first three, we got 21, 18, and 12. We add those and divide by 3. 10, 11, 51 divided by 3 is 27. Is that right? And then if we did 21, 18, and 12, or 21, 2, 4, 6 divided by 30, or 3, that's 30. So
So
just
it's going to
using
go
those
up.
three,
Wait, are you adding them all and dividing?
because the median is when you
Oh,
add
oh.
all and divide, right?
No, no, no,
I
no.
thought the
Oh,
median
you
was when you cross off the highest and the lowest, and you keep working your way towards the middle.
Yeah, I
uh,
did the same mistake because that's the mean.
oh, that's
Yes,
right.
Because we're just so used to calculating mean for everything.
Yes.
that is the
All right.
truth.
So 12 is really going to be an outlier, right? Like
Yes.
they probably interviewed people between 18 and 25 or like around
Correct.
that. So 12 is going to be on the way end of this one. And so it was crossed off way before. But if you put it near the middle, anyways, it's I think the median, I don't know.
I'm actually doing it right
I
now. I'll know in a
I would
few
kind of
seconds.
think it would stay the same because the median is 21.2, so it's going to fall right by the median. So isn't it going to stay right close to where?
I think it'll increase slightly. I don't know. We'll see here. 20, 21, and 20.
Does does the n and standard deviation and mean, does that have anything to do with figuring out median or
No.
right? Like
So basically what's going to happen is that 12 changes to 21, so that data figure just jumps towards the middle, which is close to the mean, and it's only one data point.
So
I don't know.
Yeah, I don't know. I think for this,
it went up because the center number when I did it with the original set of data was 20, and then when I changed it to 21, the median then became 21. So I think it increases.
yeah, I'm gonna say it either increases or we can't figure it out without the list because you have to cross off every single one and find the middle. So the middle is going
Okay.
to change with where it's lined up. So I don't know.
Yeah, that's true. We only got to do it with like 5 numbers versus all of them. So I don't know.
All right. Let's go with increase and then see what we can take it twice, right? So
Yeah. Well, here I'll put the I'll put that it doesn't change, and then we'll see what we get.
Okay, sounds good.
are you putting that it doesn't change, or are you putting that we can't determine?
Sorry. Yeah, that's the third. The third.
I'm a little frustrated because I went through the questions. I actually printed them up and wrote on it because I wasn't sure how my internet would be here today.
Uh-huh.
But the answers aren't in the same order that they are here on this dumb quiz.
Oh,
It's the same answers, they're just not the same order.
oh, they're like
And
jumbled.
yeah, it's okay. It's not something I can't make sense of. So
Okay.
keep going.
All right. The time to complete a standardized exam in the BYUI Testing Center is approximately normal, with a mean of 70 minutes and a standard deviation of 10 minutes. Using the 68, 95, 99.7 rule, approximately what percentage of students will complete the exam in under 50 minutes?
Oh man, I forgot this rule.
Yeah.
So the
Oh. I think I
90,
remember it.
isn't that like one standard deviation, two standard deviation, three standard deviations away from the mean?
Yeah. Yeah.
And so if 70s are mean, then 50s two standard deviations away? Is that what the question's asking? In under 50 minutes, so it's less than two standard deviations away? Am I think? So basically, but that covers, so if we do that little, like you have the mean in the middle and then one standard deviation, it kind of is the spectrum of the whole, right?
Actually, I'm gonna.
So what's 7 minus 95?
Well, I was thinking it falls in the 68 percentile, but it's only half of that 68 percentile, right? So could it be 34%? Or is that not the way we figure it
So
out?
I think it's going to be 4.7, and this is why. So I don't know if this made sense to me. How do we? So if our mean, I'm trying to figure this out because everything's backwards now. But if this is the mean, and then that's one standard deviation away, and that's 2, and then that's 50, and we're trying to find under 50, and everything past this is 99.7%. But that includes all of it. So I guess I'm saying, like, what am I saying? I just basically did 99.7 minus 95 to figure out what was just below 50. And I got 4.7. But I don't know if that was right. It made sense in my head. I thought there was a way to just plug it into a formula where it's like,
Pick a set.
just to find
Yeah, I
like
could.
exact. Can't remember.
I'm kind of looking at a chart on Google, and what I'm getting is it might be just 0.1%.
So 68% of the data falls within one standard deviation away from everything. Is that right?
Yes.
Mm-hmm.
And then 95 is 2 standard deviations.
Yes.
Correct. Yeah.
Okay, so wouldn't 50 falls right at that 95, correct? So it's everything outside of 95
Correct. So between 2 and 3 standard
is,
deviations.
but it's only half of that because that kind of gives us both spectrums, above and below, correct? So we have to divide that by 2.
That's what I did.
Wait.
Because we're just doing less than 50 minutes. I don't know, we shouldn't be adding everything together.
Right. Okay.
No? Are we overthinking this one?
I'm gonna show you the graph I'm looking at, and let me know if it makes sense to you.
Okay.
Okay. Can you see it at all?
Yeah?
Yeah.
So my guess is that the blue here is the mean. So we've got 1 standard deviation, 2 standard deviations. Now I feel like it would be everything from like here over, which is saying it's 0.1%. Yeah,
Yeah.
that would be my
Well,
guess.
So is it 2.2?
1, 2. So I think. Oh yeah. That's what I think. 2.2.
2.2.
Yeah.
Okay, I'm good with that. 2.2.
Okay, let's give that a
Okay,
shot.
that's percent. We have to write it as a decimal. So it's 0.022, right?
But we only have room for 1 decimal place. So maybe that's not the answer then.
Okay, I don't know. Oh boy, this is fun.
Unless you
Okay,
just
we
do
got.
2.2.
Yeah,
Let's do 2.2
yeah,
and just let
I
it
think it is.
move on.
Okay.
Good.
Yeah.
How we figured it out, yes. If it's not right, we'll spend time on our own figuring it out. And if anyone
Yeah,
figures it out, let's go.
or email the TA or something.
Yeah.
Yeah.
Okay.
Okay, question 6. The scores on the LSAT are approximately normal with a mean of 150.7 and standard deviation of 10.2. Queen's School of Business in Kensington, Ontario requires a minimum LSAT score of 157 for admission. Find the 35th percentile of the LSAT score accurate to 1 decimal place. Use the applet.
Ah,
So I think this is the one where we have to solve for a z-score. I don't know. This is one this is one I still had a question on. So, okay, so this one, what I wrote in my notes is type 0.35 in the area of the applet and shade to the left, less than. And that gave me a z-score of negative 3.385, and then now solve for x in the z equation. Does that make sense?
Okay.
Can you repeat that again?
So I took in the applet, up in the area place,
Uh-huh.
I typed 0.35, and I only shaded to the left because up to the 35th percent, or to the 35, right? So it's everything to the left, and that gave me a z-score of negative 0.385. And then I plug that into the z formula and solve for x. I don't know if I did that right. That was when I was questioning.
Okay.
So the answer I came up with is x is equal to 160.927.
So wait, so once you have the z-score, what do you do with that again?
I didn't have a z-score. Oh, wait, the z-score, yes. So then
In the applet?
okay, so then I plugged that into the z-score formula because we don't know x. We want to know what x is, right?
Well, I think we already know what x is, but
How do
or
we know what
sorry,
x is?
because it was given that um, requires a minimum of 157. So whatever that would be like x bar or whatever.
Right. That's the x bar
Okay.
minus x, right?
Okay. Right.
So z
And then
equals
it's
divided by the 10.2.
and then so where does x fit into that one?
Maybe it's not x that I'm talking about. It's
Right.
not x. It's mu.
Sorry.
Sorry, we're solving for mu. So it's the formula for a z-score.
Okay.
Z equals x bar minus mu divided by sigma, the standard deviation, right?
Well, so I think we're given all of those numbers, all those three numbers. 150.7, 10.2, and 157.
Okay.
But I think isn't there what's the one where it's like x bar minus mu over sigma or like something minus sigma?
I don't know, but the 35th percentile comes in there somehow.
Right. No, yeah. And
That's why I was saying.
no, right. I was just waiting for that other number. And yeah, I'm seeing here is z equals x minus mu over sigma. So how do we?
I think what it's asking us to find is a score, an LSAT score that is the 31st percentile. No?
Oh, I guess that's true. Yeah. Right. So that what they require doesn't matter because that's not what they're asking.
I think.
Okay. No. Yeah. Okay. I'm sorry. You're right. And you're right. It's not x bar. It's just x.
It's mu
You're right.
or x or something.
Yeah.
Whatever all those.
I think we're solving for x because mu is
The
the
mean,
mean.
not, but we're looking for a specific like data point, right?
Right. I get you. So it should be negative 0.385 equals x minus 150.7 over
Is it
10.2?
x minus 157 or 150? Or is it 157 minus x?
I think it's x minus 150.7.
And then divided by 10.2?
Yeah. I think I don't.
Or is it the square root of 10.2?
Oh, too many.
Yeah. What's that one? Can't remember.
Yeah, I can't either.
I think
So,
that's when sigma's not known or something, and so then we're
oh, that's right.
yes.
That's
That's
right.
when we have to.
I got 146.8 rounded.
Yeah, that's what I just got.
146 what?
0.8.
0.8. Okay. Let's give it a whirl.
Okay. Yeah, we'll see on that one. All right. A team of dermatological researchers were studying skin cancer among 60 to 70-year-old American men. Suppose you were a part of the research team and take a sample of men from this age group and calculate the mean number of skin cancer spots in the sample. Also suppose that it is known that the distribution of the number of cancer spots is right skewed. Suppose the sample size for this study was n equals 2. What would be the shape of the distribution of sample means? It's it's
Wouldn't
going
it?
to be skewed right because that's what the parent is, and then n isn't big enough to make it normal.
Yeah, and is way too small.
Exactly.
Yeah, I don't know why you do a study and only
Good.
do it on 2 people, but
Exactly.
Yeah.
Okay.
Okay, so next one is use the following information to answer the next two questions. Tanker trucks are designed to carry huge quantities of gasoline from refineries to filling stations. A factory that manufactures the tank of the trucks claims to manufacture tanks with a capacity of 8,550 gallons of gasoline. The actual capacity of the tanks is normally distributed with a mean of mu equals 8,544 gallons and standard deviation of, what does that symbol mean again?
Where is it?
Is it
How about that?
is it alpha or no? It's like
No,
the last
sigma.
sentence.
Sigma.
Sigma equals 12 gallons. And question 8 states, suppose that a simple random sample of n equals 20 tanks is selected and the sample mean capacity is found to be 8,550 gallons. What is the z-score corresponding to this sample mean? Round your answer to 3 decimal places. Whew.
So this one is going to be 8,544 minus 8,550 divided by 12 divided by the square root of 20. Is that right?
Five, four, four. I think you're right. Minus 8,5. Oops.
So, like, I think so too. I'm just trying to like figure out for when I take the test by myself, like, like
How do you
why,
know
like
what you're
why
doing?
did right? Well, I mean, yeah, that's always what I'm thinking, but like, why we're using this formula for this question and not this formula for the last question that we did, right? Because we were given standard deviation in both, an n in both, and we're trying to find the z-score in both. So I'm just trying to figure out, like,
It could be without the square root of 20. It could be just 12. And I don't know the answer to that.
okay. Thanks, guys. What the heck? I'm just kidding.
Well, I'm
I'm gonna look it up. Just real
I'm
quick.
thinking when sigma is known, we use the z-test. When sigma is not known, we use the t-test, and that's where we divide by the square root of n. We divide by the square root of n for the z-test, do we?
You said we
After
use
the
the z.
z-test.
You said we use the z-test, right? When we know the sigma.
I'm thinking,
Okay. That's
and
what
it's
I thought
telling
too.
us to find the z, right? No? Yeah, it does say the z-score.
Yep.
Okay, so yeah, so the first one is to find the z-score. That's forget about n when you're finding the z. And then
So it's
the other formula, I think,
t.
is when you're talking about distribution of sample means. We use sigma divided by square root of n. So yeah, I think we're just going to use the same one as
Divide by
last time.
12 here, right?
Yeah. Just 12. I think. My quick little research.
What chapters does one test score, blah, blah, blah.
Do you guys get negative 0.5?
One sec.
8, 5, 14, minus. I got negative 0.5. Did I put the numbers in the right place? So 8544 goes first, and then we subtract the 8550.
Yeah, that's what all three of us got. So whatever we did it the same.
But then you look at it and we're supposed to be rounding to 3 decimal places.
Yeah, that's kind of making me scratch my head too.
So I'm wondering if, well, and then I just did the one involving n, and I got negative 0.1118, blah, blah, blah. So I'm like, are we
I
supposed
got
to be using
negative
that one?
2.236 for when I did a square root of 20 with it.
Well, that's interesting.
Wait, and then are we doing, what's the formula again? X first, or is it mu first?
Mu, no, x bar minus mu. What's the other?
Okay, no, yeah. X bar minus mu
Okay,
over
chapter 5 is scores.
sigma divided by square root of n.
So z is equal to.
Duh. Yeah, okay. I just wrote it down wrong.
So what did you get this time? Did I
got
write it wrong or?
I just got positive point. 1118.
So it should be 8550 minus 8544.
Yeah.
Where's where I went wrong?
All divided by 12?
Well, I think
Or
we're
12.
yeah, I think 12 times square root of 20.
Be back by 5.
12 divided by the square root of 20.
Okay.
Oh. Yep. Yeah. Okay, what did you get? 2.236.
Wait, were we getting the different answers because we didn't do the square root?
I think so, but I think I messed up because I didn't put divided by. I put uh I, I put the bottom numbers multiplying each other.
Oh, okay.
2.236. Yep. I'm good with that.
Okay. Okay, so number 9. Is everyone ready for number 9?
Yeah.
Okay. So, what is the probability that the sample mean capacity of 50 randomly selected tanks will be greater than 8,540 gallons? Round your answer to 3 decimal places. Okay. So, which formula are we doing for this one?
I think if we find the z-score with it at 50 instead of 20, then we put it in the applet and get the percentage. Is that correct?
I think so. Yeah.
Okay. Hmm.
Oh, so wait, so
No?
let's see. Wait, and then we're gonna do. Well, when are we gonna shade? Just to the right, right? What after we find the z-score?
Greater than that number, yeah. Because we'll find the z-score for it, and then it's going to be greater than. So it's be to the right of it. Right?
Yeah. So z-score is 0.5.
I can't figure out the z-score. Divided by
Yeah, and then I got area 0.309.
what was the score you got?
What's that?
The z-score.
0.5.
I think it's 0.5. I have 3.536.
Oh, dang it. I think I was just using the z-score we found last time. I didn't realize it was a different number. 8540.
Yeah.
Okay, sorry.
And is different.
Oh, what the heck? Why did they? Okay, that's weird how they just said like, oh, these two are kind of the same. They're not really the same at all.
Well, it's still the same
Right,
meaning.
like few numbers, yeah. Okay, let's see. But for z-score, um, number's not going to affect it, right?
Yes. Mm-hmm. So these scores turned out to be too high, so something's wrong.
I just got -0.333.
What am I doing wrong then? You have 8550 minus 8540 divided by
No, no,
12
no. I have
divided.
I have 8540, which is the new x, minus mu, which is still 8544. And then divide that by standard deviation 12. Right, because we need to find the z-score first.
Okay. So what's the answer?
Well, for that one, I got -0.333.
Hmm.
And then plug that in the z-score.
And we're shading just to the right of it.
Yeah. And so it should
And so that
be
gives us 0.63.
Yep.
0.
Yep.
Mm-hmm.
Okay.
I don't know. I feel like
Eh,
I don't know.
It's okay. Just we'll see how it ends up and
Yep.
figure out which ones we miss and why we missed it. Okay, question 10. Which one of the following best describes the notion of the significance level of a hypothesis level? The significance
Hypothesis
level is
test.
it's the probability. Did I say level test?
Yeah, I was like, wait, what?
It's the probability of a type 1 error.
It is?
Yeah.
Okay, cool.
Sweet.
All right. Unfortunately, I do have to get going though for my test
Okay.
and my other assignments.
Okay.
But yeah, I'll email you guys if I have any questions or anything.
Okay. Sounds good.
Alrighty.
Okay, I'll see you guys.
Thanks.
See you, Micah.
Bye.
Oh gosh. Yeah, we have a lot. Okay. We'll
Yeah.
speed through.
There's
My bad.
43.
Okay. The
No,
height.
no, it's just I had
Oh man.
questions going through this last night, and I don't know if it was because it was late or I'm just screwing myself up trying to keep it all straight.
No,
Okay,
yeah.
next question.
Okay. The heights of young adult females in the US are said to have a population standard deviation of 2.6. A sample was taken of n equals 85 young adult females at BYUI, and the mean was computed to be x bar equals 65.4. Which of the following explanations describes the correct way to interpret the 95% confidence interval for this problem? We are 95% confident,
That the true mean height of adult females is somewhere in our confidence interval? Yeah?
and then
The 95 of 95.
that one too?
Approximately. Yep.
Okay, sweet. Because, yeah, that was the one I was looking at. Awesome.
All right. Marine biologists have been studying the effects of acidification of the oceans on weights of male beluga whales in the Arctic Ocean. One of the studies involves a random sample of 16 beluga whales. The researchers want to create a 95% confidence interval to estimate the true mean weight of male belugas. Their data follow a normal distribution. The population standard deviation is 125. and the researchers feel comfortable using the standard deviation for their confidence interval. Are the requirements for the use of a confidence interval met? I think I was saying n is 16, so it's small.
Right.
So is it not?
Wait, is the data follows a norm? Oh wait,
The data
requirements
follows
for
a normal so I have the requirements is a simple random sample, and X bar is normally distributed, which means the population is normally distributed, the sample size is large, and sigma is known. But
so I think that if the if the parent is normal, or yeah, their data follows a normal distribution, then that overrides if n needs to be large enough, because n's kind of just your backup.
okay, so you're going to say yes because the distribution of sample means is normal because the
Yes.
data are normal?
Yeah.
Okay.
But then, yeah, if not, then I guess it'd be no, because n is small. But I think I'm pretty sure it's that one.
Okay.
Okay, so, yeah. Okay, 13. An investor with a stock portfolio worth several $100,000 sued his broker and brokerage firm because he felt that lack of diversification in his portfolio led to poor performance for many years in a row. In an effort to avoid close public scrutiny, the firm agreed to settle the conflict by an arbitration panel. The arbitration panel compared a sample of 39 months of the investor's returns with the average of the Standard & Poor's 500 stock index for the same period in order to determine whether there was a substantial decrease. The data are recorded in rates of return. The S&P has a known population mean return of 0.95. So suppose you're a member of this panel, conduct a hypothesis test to determine if the investor's portfolio performed significantly worse than the performance of the S&P. Use a level of significance of 0.05. What is the p-value?
So it's less than, right? Did
Yes.
you copy this data already?
No.
I got 0.019.
Sounds good. Because, yeah, I haven't even downloaded it yet, so I'll check it later.
I just went through last night. I did, so.
Okay, perfect, yeah.
Okay.
Oh, sorry. Go.
A financial economist is studying married couples in which both spouses work. He wants to compare the mean income earned by husbands with the mean income earned by wives. Should he use independent sampling or dependent sampling, and why? Dependent, because hers is the wife, whether she's included depends on him. Good.
Yeah, you can't just match up whoever you want.
Okay.
Okay. Pressures of supply and demand act directly on the price of airline tickets. As the seats available on the plane begin to fill, airlines raise the price. If seats on a flight do not sell well, an airline may discount the tickets or even cancel the flight. Allie Henrich, BYU student, wanted to determine if there's a difference in the price of tickets listed 90 days before a flight compared with 14. For her study, she compared the prices of one-way flights from London to various destinations in Europe using Travelocity.com, recorded the lowest published fares for 90 nonstop midweek flights 90 days in advance, and then found the lowest published price for the same destination again 14 days in advance. The prices are given in the file direct flight costs. What is the p-value?
So this was one where I was wondering, this is a paired sample, right? And how do you determine which is variable 1 and which is variable 2?
Does it
Because you
make a difference?
subtract one from the other. I don't know. I'm
Oh, that's right.
I did do it. I did it last night one way. I'm going to do it right now real quick the other way and
And
see
we'll
if I
just
get
plug it in.
a different answer.
Okay. No, because you're right. You do have to subtract one, so
All right.
it would
And
at
then
least.
we had a significance. Do we put a null hypothesis in for this? It's a paired sample t-test, right?
Yeah. Yeah, I guess just assume 95 then.
I got the same p-value, 0.096.
Okay, awesome.
Works for me.
0.096, is that what you said?
All right. Based on the results of the test, can you say that there is a difference in the cost of airline tickets purchased 90 days in advance compared with 14 days in advance? Use a level of significance of 0.05. So p-value is greater than alpha, so we fail to reject. So there's no difference, right? I mean,
Let's see. So, yeah, hold on. So P is greater. Yeah, so we're going to fail to reject the null. And the null is stating that there's no difference. So we're going to fail to reject that there's no difference.
okay.
Right? Or
We can say there is a difference because the null was that they are equal. The alternative is they're not equal.
correct.
Right?
Yes.
And so we can say there is a difference. So we're saying yes, and p-value is greater than level of significance. Yes, because the p-value was greater than the level of significance, right?
Okay. Yeah.
Okay,
So
good.
So when, sorry, I'm just going to write a note. So when P is greater than alpha, that means that there is a difference, right? Like, okay.
Yeah. Because that means that the... Wait, no, because we failed to reject. Rejecting the whole hypothesis. Where's my little cards? If we have insufficient evidence, so we don't have enough evidence to say that it is different, that they're not different. Oh, I don't know. I'm getting myself screwed up in wording. Is there a difference in the cost? No, because the p-value was greater. I think it's no. Because if we fail to reject, we have insufficient evidence to say, and then we state the alternative hypothesis. Am I confusing myself and you?
Right, but okay. Gosh, this part is like the biggest headache. So sorry, can you say that one more time?
I don't know what I said. It's saying based on the results, can you say there's a difference in the cost? Which is the alternative hypothesis, that there is a difference, and we can't say that because we don't have sufficient evidence.
Correct.
So no, we
Correct.
can't say that because the p-value was greater.
Yes.
No, because
Correct.
the
Correct.
p-value was greater than the level of significance. All right. No, because, okay, good. Move on. Stop confusing
Awesome.
myself. Oh.
So yeah. Okay. All right. Real estate company wants to evaluate 2 of their home appraisers for consistency and prep for their annual state certification. It is important that different appraisers be able to give similar estimates for homes and other properties. The company selects a random sample of 10 homes in different neighborhoods around the city, independently asks each appraiser for an estimate of the home value. After they receive the estimates for each home, the company subtracts the value given by the first appraiser from the value given by the second appraiser. Subtract. So what is that? First minus second? Yeah. Yeah. Create a QQ. See that the points in the plot roughly form a straight line. Are the requirements for using the desired confidence interval satisfied? It's not the first one because n isn't large enough. What are the requirements for
The requirements for a paired sample t-test is the same as a one sample t-test because you subtract them and then you do it. But I have here QQ plots and question marks. So I'm thinking that there's something in one of these quizzes or something that made me think, like a question like this that's saying, what does QQ plots have to do with this one?
Okay. Yeah.
Okay. Give me just a few minutes. Sorry. So what I wrote last night was, yes, the distribution of mean difference is normal because the data have been determined to be normal.
Yeah, that's the one that I'm looking at.
Let's go with it.
Okay, because yeah, the other, yeah. Okay. 18.
But I still need to find out about QQ plots on this one and double check my stuff.
Okay.
All right. I stapled my papers wrong, or something did something wrong here.
All right, now suppose.
So we're on 18.
Yeah.
Okay, go ahead.
Now suppose the company wants to use a hypothesis test to determine whether the estimates given by the 2 appraisers are different. Which of the following would be the appropriate? It'd be null, equals, alternative, not equal.
It'd be the UD one, where U sub D equals 0 and U sub D doesn't equal 0.
Right,
Because
the differences.
Because it's a paired one, so we're doing their differences.
Yeah. Okay, no, yeah. Let me make an extra note because I think I ran by that too quick.
I had to look, and I have that paper that I did up like this, where it's got like all the set tests,
yeah.
and then that's my little cheat sheet to see which test requires what. Okay. I got about 10 minutes left, and then I need to get going. We still have half the quiz to go. But I know that some of them are pretty...
But yeah, well...
I got quicker as I went through.
Well, I think I'll just
So let's keep
save
going.
it because I don't think I can get through this whole thing either. I'm gonna have to leave
Yeah.
in 10 minutes too. So
Okay, let's go as far as we can. Suppose you create a 95% confidence interval for a mean and get this confidence interval. You've been told to report 95% confident that the true mean is between -2 and 8. Exactly what does this mean? I got my go-to is 95% of all 95% confidence intervals actually contain the true mean. Because that was something in the book and I like bolded it in my notes. So what I have in my notes about confidence intervals is 3 different ways that it was stated in the book. We are 95% confident the true mean is between these two numbers. If we repeat the process many, many times, 95% of the confidence intervals will contain the true mean. And of all 95% confident interval contain the true mean.
sweet.
So
Yeah. So
that's where I get that.
yeah. Perfect. Okay, if p is 4 over 5, what's the smallest value of n that satisfies the requirements for a normally distributed p hat?
So this is the one where we have like n is greater than equal to 10, and n is greater than or equal to, I mean, not 10, yeah, 10. N times p is greater than equal to 10. That's what I'm trying to say. And the n times 1 minus p is greater than equal to 10.
Okay.
So it's dealing with that kind of stuff. And so we have to solve, this time we don't know n, we know what p is, and we have the 10. So then we have to solve for n in both those equations. And I got 50 as the
Perfect.
number. But does that?
No, yeah. I remember that. Okay, your little brother has a RBI of 0.233. You want to determine the probability that he'll have a better average of over that next season when he'll be up to bat 40 times. Are the conditions met so that p hat will be approximately normal? So it's the same thing, right? But
Yep.
you have n.
Yeah, and so I just plugged in the n, and so n times 0.233 is less than 10, so that's not sufficient. It actually needs to be like 43 because I solved for n to
Okay.
know what it would be as I'm figuring it out. Okay, 22. A geneticist takes a simple random sample of n equals 140 from the testes of a dog to determine the proportion which contain the chromosomes for development to a male. Assume the unknown true proportion of dog gametes that contain the male chromosome is 46%. The geneticist conducts her survey and calculates p hat to equal to. Which of the following is the most correct interpretation of this statistic? I guessed. I don't know.
Okay. So yeah, just gonna have to figure out what p hat really means, right?
Yeah.
Okay.
I don't think it's the first one. Anytime it says chance, it's never
Right.
one
No,
of the
yeah.
answers.
Yeah.
And I don't think it's the eggs fertilized with these gametes. Oh, yeah, it won't be because that has to do with female puppies. And yeah.
Right.
So
Right. That
it's the
was a part of the
bottom
study.
two. I think it's 51.2 of the gametes in the sample have
Yeah.
the male chromosome.
Right. Right. Because we're just figuring out the sample.
Yeah.
We can't say that all dogs, like 51 in all dogs have this. Unless P hat is saying that, but oh, maybe it is because we're just trying to find probability. I don't know, either C or D. So.
All right, I'm doing D.
Okay, I'll do C.
Researchers published a study in which they considered the incidence among the elderly of various mental health conditions such as dementia, bipolar disorder, obsessive compulsive disorder, delirium, Alzheimer's disease. In the U.S., 45% of adults over 65 suffer from one or more of the conditions considered in the study. Calculate the probability that fewer than 320 out of the N equals 750 of adults in the study suffer from one or more of the conditions under consideration. Give your answer accurate to 3 decimal places. I didn't get an answer to this one.
Yeah, well, I'm wondering if
Is it just 320 divided by 750? But it has to be fewer than that. So then that's got to do something with the applet, right?
I'm wondering if, yeah, I don't know. Like I was gonna think like, well, if we turn the other two numbers into a percentage, then we can use the 45% as like the parent data and then solve for z-score. But it's like, oh wait, no, you can't because you don't have
all the information.
Right. And then N would be like 100% or something, and that wouldn't even make sense. So never mind.
Okay. I think I'm just going to type something there or figure that one out later.
Yeah, me too. Suppose you're testing null P equals 0.62 against alternative P not equals 0.62. And you've calculated the test calculated Z 1.334. The area to the right of Z is 0.091. Which one of the following is the p-value of your hypothesis test? So
it's not equal to, so it would say both sides, right?
Yeah.
So is it 0.091 times 2?
Oh my goodness! Really?
Is that right?
Like we just did 0.091 into z-score, right? Did both sides?
It says it's shaded. The area to the right of the z-score 1.334 is 0.091. So that's saying that they just shaded to the right and they got 0.091. But this is a not equal to test, so we have to shade both sides. So we just need to multiply that by 2. Okay.
Gotcha.
Alrighty.
So what did you end up getting for that one?
0.182.
Oh, duh, because it's just okay. Okay.
Alrighty, I'm gonna need to get going.
Yeah, me too.
I'm so sorry.
No.
Finish, but
I know. I would too.
Together.
Okay, for sure. Maybe when we do get a chance tonight to kind of go through it and then we get our stuff back, maybe we can kind of all email each other and see kind of,
what we got, where we at.
Yeah.
Okay.
Okay, sounds good, Christine.
Thank you. All right. Bye.